Every morning when you open your eyes, you see a new world, joyful or sad, dangerous or safe, filled with bright colors or immersed in gray half-tones. One way or another, you see it. You can assess every detail. You can estimate the distance to any object, reach it, take it in your hands, feel its weight, or simply bypass it. And all this thanks to light. Without it, we would be deprived of a huge part of the sensation of life. But what is this very light? At first glance, everything seems perfectly clear. But the more we delve into its study, the less we understand whether it is a wave or a stream of particles, or both. How is this even possible? How does the observer effect occur? There are more and more questions, and although there are answers, they suffer from some kind of one-sidedness, incompleteness. It feels like scientists are hiding our ignorance behind strange formulas. We clearly lack some very deep part of understanding in our worldview to explain what light is. Good day. You're on the Epoch of Distrust channel with Mikhail Kalmykov. And now we will try to figure out in the intricate labyrinth of answers, which gives birth to only one question: what is light? And who knows what unexpected conclusion this path will lead us to with you. So let's start from the very beginning with school. We open a physics textbook, the optics section, and read, light or visible radiation is electromagnetic waves that cause visual sensations in humans. Only waves with certain frequencies have this ability, and so on. That is, straight from school we are told that light is a wave, an electromagnetic wave, and that's it. Because probably a deeper knowledge will not be useful in a person's further life at all. Indeed, all optical effects, everything that we can apply in everyday life, entirely and completely relies on this assertion that light is a wave. And we don't need anything else because everything works clearly. This version was first justified by Christian Huygens in 1678 in his treatise on light. A brief note: Christian Huygens, one of the most brilliant scientists of the 17th century, was born in 1629 in The Hague, lived 66 years, and managed to make his mark during this time. In mathematics, geometry, mechanics, astronomy, physics, he showed himself to be a genius in all spheres. For example, in mathematics, he worked on the squaring of the hyperbola, ellipse, and circle. He developed a general theory of evolution and evolvement, worked on the theory of continuous fractions, and essentially became the founder of probability theory. He defined its basics and introduced the fundamental concept of mathematical expectation. Thanks to him, we got the 100 clock, for example. Then he invented a clock spiral, which will replace his own pendulum in the clock in the future. He invented a diascopic projector, which was essentially the first prototype of cinema. He formulated the Huygens principle, which allows the study of wavefront motion. In other words, a genius of his time. However, most ordinary people, if they have heard of him, probably associate him with the name of one of the probes of the Cassini spacecraft, launched in 1997 by the European Space Agency to Saturn. This probe was named Huygens, and it got its name not just like that, but precisely because Christian Huygens himself described the rings of Saturn, and he discovered one of its satellites, Titan, where, in fact, the same name probe was launched. However, his name is now little known to the general public compared to, for example, Carl Friedrich Gauss, whom I mentioned in the film The Great Permian Extinction. Yes, their stories are actually quite similar. Both made a huge contribution to their fields of science. Both developed revolutionary methods and devices that institutes still work with to this day. But something went wrong, and their names were forgotten, erased from history, forgotten by the general audience. Academic circles never forgot them. As I mentioned earlier, their devices are still in use to this day. Why did this happen? Well, we've poorly dealt with Carl Friedrich Morrow. His theory of the geological origin of coal rocks goes against the currently accepted theory of evolution and development of the Earth. Over the course of 4 billion years, he lost the scientific battle even to his colleagues, chemists and geologists, about some shake from 2 priests and a soldier. Sad. But to whom did Huygens lose, and most importantly, why? You surely know the answer to the first question, don't you? And if you don't know, you can surely guess. He is another genius of the 17th century, only 30 years younger than Huygens himself. His name is Isaac Newton, as evidenced by Newton's own preserved record. At first, he was a proponent of the wave theory of light and asserted that different colors of light, when refracted through a prism, are associated with different wavelengths. The longest waves are red, the shortest are violet, and all other colors are in the range between red and violet. In principle, it's exactly what we know with you now. However, later, after Huygens' death, in his treatise Optics from the year 1704, he radically changed his decision. I justified this with a simple logical conclusion that, since light does not die out, encountering obstacles on its way, similar to a sound wave, then it cannot, accordingly, be a wave. And therefore, light is a stream of particles, corpuscles, because pressure or movement cannot spread in a liquid in straight lines around an obstacle that holds back part of the movement. They will bend and spread everywhere within the resting medium lying behind the obstacle. He compared it to a liquid, possibly ether. It's strange that such a great scientist didn't take into account the phenomenon of diffraction and interference, which exactly proves the wave structure of light and simply his insane speed. To anyone, even the most uneducated person, it should be clear from their own personal experience that the difference in propagation speeds between sound and light is simply colossal. And if the speed of sound can be measured quite simply, even without any special equipment, then such a trick won't work with light, which means, and the deviation of the light wave from a straight course. If it does happen, noticing it is much more difficult. Nevertheless, it exists, and Newton himself knew this perfectly well. In other words, this proposal seems to me to be extremely thoughtful. Nevertheless, from that moment, or more precisely, from the year 1774, the corpuscular theory began to be born. It must be said that the corpuscular theory could not ultimately defeat the wave theory of light, and a compromise was reached in our time. And with the help of quantum physics, the corpuscular wave theory was born. In fact, quantum physics was born to somehow explain phenomena that, apart from the presence of ether, simply cannot be explained. But we will return to this. For now, let's fixate on this intriguing moment. Newton began to advance the corpuscular theory, not only of light, but of everything in general. But the main adversary, the main principle that Newton was trying to eliminate, was of course not the nature of light. It was in general secondary. The point is that in Huygens' wave theory, light moved not in empty space, but in the world ether. And it is the ether that is the very enemy that Newton sought to eliminate. And he unashamedly writes about this, in fact, in his treatise Optics, Part 2, Question 28. To explain the unusual refraction of an Islamic crystal by spreading pressure or motion has not been attempted, so far as I know, with the exception of Huygens, who proposed 2 different oscillating mediums within such a crystal for this purpose. But when he tried to study the refractions in 2 consecutive pieces of this crystal and found that they occur as indicated above, he admitted himself that he cannot explain them. because the pressure or motion spreading from the luminous body through a homogeneous medium should be the same from all sides. Meanwhile, it is clear from experiments that rays of light have different properties on their different sides. He suggested that the pulsations of the ether passing through the first crystal could receive certain new modifications, which determine whether the pulsation will spread in one or another medium inside the second crystal, according to the position of this crystal. What kind of changes are these? However, he could not say or think of anything satisfactory in this regard. If he knew that the unexpected breakdown depends not on new changes, but on the initial and unchangeable positions of the rays, he would have found that. However, it is difficult to explain how these positions, communicated to the rays by the first crystal, according to his assumption, can exist in the rays before they fall on this crystal. And in general, how can all the rays emitted by luminous bodies have such positions in themselves from the very beginning? At least to me, this seems inexplicable if light is nothing more than pressure or motion, propagated through ether. It is also difficult to explain with this hypothesis how rays can be alternately in states of easy reflection or easy transmission. One can only assume that there are two ether oscillating mediums existing throughout space, with the oscillations of one constituting light, while the oscillations of the other are faster, and every time the latter overtakes the oscillations of the first medium, they induce the specified states in them. However, it is unclear how two ethers can be spread throughout all space, with one of them acting on the other and consequently experiencing resistance, not delaying, not disturbing, not scattering, and not confusing each other's movements. Against filling the sky with liquid mediums if they are not excessively dispersed, there arises a great doubt in connection with the correct and very long movements of planets and comets along various paths in celestial space. For it is clear that celestial space is devoid of any noticeable resistance and, consequently, any perceptible matter. It was roughly from these words that the battle with the ether began, and Newton became the head of this battle. And that's why it's worth taking another brief excursion into his history. The thing is, Newton's discovery and contribution to science are far from as straightforward as they are taught in school. For example, his famous theory of gravity, which he first published in the late 1680s, borrowed heavily from Robert Hooke's theory, who had formulated all the basic principles of planetary motion. As early as 1666, that is, 21 years earlier. However, he was unable to derive the formula, but in his diary, he accused Newton of plagiarism. I showed that Mr. Newton used my hypotheses about impulses and waves from Gouke's diary. Either way, 2 years after the release of Newton's principles, under pressure from the Secretary of the Royal Society, Gouke and Newton exchanged conciliatory letters, and the conflict, it seemed, subsided. However, after this, and until Gouke's death, Newton did not publish his works on wave propagation, and the relations remained strained. And yes, the correct formulation of the law of universal gravitation belongs to Gouke, not Newton. In general, the story is quite strange, because if Newton was 100% sure that all the work was his, then why would he keep silent for 20 years and then wait another 26 years after the conflict until Gouke died? So it turns out that Newton said he discovered the law of universal gravitation before Gouke, but just kept silent for 20 years. And what's that? And only when Gouke claimed his priority, only then did he say that he had done it earlier. Well, okay, it could just be a coincidence. We are all people, aren't we? But no, a very similar story with Newton's astronomical discoveries. In particular, to develop his theory of the motion of celestial bodies, Newton needed precise astronomical data about the position of the moon, planets, and stars. By the way, he had to get acquainted with John Flamsteed, who was then still a student at Cambridge, and Newton was already a master. But already in 1673, almost simultaneously with Newton, Flamsteed became famous. He earned the title of Royal Astronomer, and specifically for him, they built that very Royal Observatory in Greenwich, from the position of which the entire planet now calculates the exact time. In general, Flamsteed provided Newton with all the necessary data for his work, and Newton did not say a word about his merits in the work, except that he casually mentioned that he used the data of his observatory for calculations. He justified this by the fact that he himself carried out all the necessary theoretical calculations, and the tables of Flamsteed simply confirmed his correctness. But fate had its own way, deliberately or unintentionally. But at that moment, Flamsteed discovered that his data on the movement of the moon, which he provided to Newton, was not accurate, and consequently the rest of the data was likely the same. And this, in turn, meant that all of Newton's work results, which had merely confirmed his theoretical calculations, needed to be recalculated. Confucius has left. There was a clear adjustment of Newton's statements to fit the tabular values. So he had to mention Flamsteed. In general, Newton urgently needed updated data, but he no longer trusted Flamsteed and deliberately delayed their transmission. In the end, the British Queen personally sided with Newton and transferred the rights to the observatory to him. Flamsteed was forced to hand over the data, and in retaliation, Newton, in the new edition of his already corrected principles, began to completely erase all mentions of Flamsteed. He soon died, and his place in the observatory was taken by Halley, the very one who discovered the comet named after him. And the first thing Halley did was to classify all the observatory data from Newton. It seems like a coincidence again. Unpleasant implications, but there's no smoke without fire. And apparently the information about Newton's total theft of ideas was already well known at that time, but even in this case, Newton's troubles did not end. Another brilliant discovery of our Isaac is differential and integral calculus, also first published in the year 1704. And again, as in the first case, it turned out that this method of analysis was developed by Leibniz in the year 1675, again 20 years before the publication of Newton's book. And again, as in the first case, Isaac Newton reported that in fact he had created this method back in the year 1665, but kept silent for almost 40 years. What of it? Apart from him, no one else would have thought of it. He was first. What is your evidence? His honest, honorable word, of course. But what else? Well, 3 consecutive, almost identical stories with fundamental revelations. It's not even a coincidence anymore. It's a pattern. The fourth story with Huygens, the wave theory, which Newton dismissed as a fanciful assumption. Fifth, Galileo's testimony, who simply blocked Newton's access to the observatory data, knowing his propensity to steal ideas. Perhaps this is why he had to invent the story with the apple? So, let's sum up. The theory of gravity, differential calculus, the motion of celestial bodies, all this was blatantly stolen by Newton from his colleagues. But to check such a thing alone, without a powerful patron, in my opinion, is simply impossible. After all, although Isaac Newton was a master of science, he still stole ideas from those who were, if not more, powerful geniuses. And he didn't just steal them, he overshadowed them with his persona. Moreover, as can be seen from history, At that moment of discovery, ideas literally fell out of the sky, and the level of these scholars bordered simultaneously on genius and childlike naivety. Something in this story doesn't add up. And indeed, there is another shadowy character who is clearly not mentioned anywhere, but whose powerful guiding hand is felt practically everywhere, and not just in science. No, it's not the English king or queen, as you might have thought. This man was called Henry Oldenburg of the Oldenburgs. He was the secretary of the London Royal Society at that time. It was through him that the disputes and correspondence of British geniuses from Hooke and Newton to Leibniz and Flamsteed went. It was under him that the explosion of discoveries of the 17th century was observed. It was he who introduced the practice of preliminary review of all scientific manuscripts by independent experts, which we still use today. This is what is known for sure. And from the realm of speculations, I believe he was one of those people from that kind who remained from the previous post-catastrophic civilization, who survived the catastrophe and passed on ancient knowledge, controlling the direction of our science's development. Their influence was far stronger and more powerful than the influence of kings. I understand it sounds quite wild, but the Oldenburgs have already appeared in my films not just once. In particular, they exerted the strongest influence on Russia, initially on Peter, and then, after his death, on the choice of our throne successor. Practically all Russian empresses are the result of Peter's intermarriage with the Oldenburg family, more precisely with their offshoots, the Holstein, Gottorps, the Kurlands, and similar Schleswig branches. The same Miller, Schlosser, and Bayer were, judging by everything, also their agents. I mention these intricacies in more detail in the film Who Rules Us? But the most complete picture of them will be if you look at where they actually came from. This can be found out if you watch the film Alien Fortresses. And it's quite possible that it's either him or someone else of the same kind. Oldenburg laid the groundwork for the fight against ether and wave theory and began to redirect science in the dead end of corpuscular theory. And this is very difficult to do if scientists work independently. And it's very easy if you yourself distribute the knowledge of a bygone civilization and appoint who will be considered a genius. But we've strayed from the main topic. The scholars of the 17th century simply had no real facts, directly confirming that light is a stream of particles. On the contrary, everything spoke exactly about the wave, although it wasn't so smooth here either. Firstly, both Huygens and Newton were puzzled by the simultaneous longitudinal and transverse oscillations of the wave. And to explain them, he, or rather Newton, introduced two ethers instead of one within the other. Such an explanation, but there was no other actually. At that time, they considered the wave propagation of compression and tension of the medium in all directions at once, and the presence of different densities and lengths of the wave sides led them into a dead end. Today we know that an electromagnetic wave is not just a compression and tension of space, but a kind of twisted three-dimensional spiral, which actually has different sides where the amplitude of oscillation is at its maximum and where it is at its minimum. In addition, the wave consists of two key parameters, magnetic and electric, so it turns out as if there are two waves at once. One moves in an electric field, and it has its own characteristics, and the other in a magnetic field, and it also has its own characteristics. Moreover, these characteristics can be diametrically opposed, and then the wave is considered synchronous and completely coinciding. Then the wave is considered in phase. That is, to some extent, Newton guessed when he assumed the existence of two ethers at once, existing one in another, although this guess looked more like a joke. Now, we call these ethers magnetic field and electric field. The name has changed, but the essence remained the same. We seem to have figured this out in advance. But the disputes about the nature of light did not subside. Young's experiment. Almost 100 years after the described events, in the year 1800, another genius appeared in Britain who was interested in the nature of light. This was Thomas Young, and he also already figured in my films. His connection with the decipherment of ancient Egyptian writing and hieroglyphs. Yes, if anyone hasn't watched or isn't aware, it was Thomas Young who proposed their decipherment to Champollion. So he disagreed with Newton's corpuscular theory and concluded that Huygens' research was much closer to the truth. He continued his work and conducted a famous experiment with two slits passing through them. Parallel beams of light can be observed on a board placed behind the plate through which the light passed. The interference pattern, which also proved that light is a wave. Passing through narrow slits, the light slightly changed the direction of movement, which Newton could not detect. After which, due to the difference in path length traversed by the waves, there was a phase shift of coherent waves relative to each other. And in those places where oppositely oriented waves overlapped each other, they mutually annihilated, creating dark spots on the screen. Let me explain what I just said for viewers with a humanities background. Coherent waves are waves that are mutually consistent with each other. That is, roughly speaking, they match in length, frequency, and amplitude. Everything except for the phase, although sometimes even the phase, that is, the starting point of motion. The comparison is rough and conditional, but it provides an understanding of the process. The waves become shifted relative to each other and mutually annihilate. Young's experiment refuted Newton's basic postulate that light propagates strictly linearly, which means it cannot be a wave and is a stream of particles. The interference pattern clearly showed the deflection of the light beam when passing through obstacles and its wave nature. Moreover, thanks to this effect, Young was the first to be able to calculate the wavelength of different colors. He calculated the wavelength of red light as 1.036 inches and the wavelength of violet light as 1.060 inches. All other colors were within this range between them. In fact, his theory was almost contemptuously tried to discredit again by Henry Brougham, the future Lord Chancellor of Great Britain, who smeared Young's conclusions with dirt, not even shying away from personal insults, and even forced Young to justify himself and publish a separate brochure in which Young detailedly responded to all the slips of the Lord Chancellor. It's interesting how such a trifle in a political sense, like the nature of light, could infuriate the actual leader of the empire. The birth of Aether? Who knows? And only almost 50 years later, in the year 1850, Gimholz's work brought Jung's experiments out of the realm of jokes. Quantum physics, the double-slit experiment, has long brought all attempts to overturn Aether and return to corpuscular theory to a halt. What can I say? The argument is ironclad. However, this does not mean that there were no such attempts. At first, all that could be opposed to Jung were mockery and howls from the side of the Royal Scientific Society and personally the Lord Chancellor. The effect was something like today's battle of historians against the theory of catastrophe. They assert that all the clay is just a cultural layer, and anyone who thinks otherwise are just clowns. But as practice shows, under the pressure of evidence over time, the historians themselves turn into clowns. Just remember the Anthropogenesis Project and their award academician Varel. It all started with the criticism of pseudoscience, and now it has turned into a farce and a clown show. Even then, in the 19th century, the first 30 years were simply a laughingstock. But after Huygens' work on wave theory and the double-slit experiment, it was no longer possible to just laugh at it. The work on the ether collapse resumed with new vigor. In order to advance the new corpuscular theory, it was necessary to essentially build a new philosophical base, create a new mindset, and accumulate enough data from side experiments. One way or another, over the next 50 years, William Hamilton, George Stoney, Wilhelm Röntgen, Henry Becquerel, Peter Zeeman, Hermann Gagg, Cornelius Wynne, Johannes Rydberg, Jean Perrin, William Thomson, and so on, and so forth, participated in this work. But the wave theory of light, thanks to their work, instead only received more and more confirmations. Finally, by the year 1900, the necessary link appeared. The German physicist Max Planck convincingly and conclusively demonstrates that light is absorbed not by a continuous beam or wave, but by individual portions, quanta. In fact, the very word quantum translates as portion, the smallest and indivisible portion. And this is already serious evidence that light indeed has a corpuscular theory. The smallest particle responsible for light has been found. However, wave effects are here to stay. An insoluble paradox arises. How can this be? Apparently, there was no time to think, because more than 50 years had already passed. Therefore, on December 14, 1900, Max Planck solemnly opens a new era in physics, quantum physics. Apparently, someone quickly realized that all unsolvable physical problems can be boldly thrown into this very black box called quantum physics, and instead of understanding the process, simply limit oneself to correlation formulas, that is, the relationship of dependence of various effects. And what? Very convenient. Any unexplainable phenomenon can be boldly called quantum entanglement, quantum effect, and calmly continue with your own business. Thus began to bear fruit quantum time effects, quantum spin entanglement, quantum elastics, deferred decision effects, quantum aromas, and similar devilry. As it suggested the presence of a large number of different quanta. After all, ahead was a whole new branch of science, so the quantum of light was given a separate name, photon, and the most inexplicable phenomenon in physics. They immediately decided to hang the banners, that is, the quanta they figured out with the light. The photon quantum is responsible for it, the gluon quantum is responsible for the vector field, the Higgs boson quantum is responsible for gravity, the phonon quantum is responsible for the oscillatory movements of the crystal, and even the chronon quantum is responsible for time. Do you feel the greatness of thoughts? We assign a quantum to each brother. And then there were electron beam tubes, called kinescopes in layman's terms, which marked the beginning of television. And there was an opportunity to conduct such a detestable two-slit experiment under new conditions. That is, to see what actually happens in these slits. And at this moment, it suddenly became clear that as soon as we want to observe which of the slits a single electron passes through, the unexpected wave interference effect disappears, and a clear picture appears on the screen, as if not a wave, but a particle is passing through the slits. Thus arose the famous observer effect, which put the whole centuries-old debate about the nature of light into some kind of stalemate, a suspended state. Another chimera appeared within the framework of quantum physics. This is the corpuscular wave theory, that is, light can be both a wave and a particle at the same time. How do you like that, Elon Musk? I must say the observer effect has not been discussed and is still only discussed by the lazy. It's understandable. The mystical transformation of a wave into a particle, the observer effect, the God effect. But the method by which they actually wanted to observe is studiously kept quiet. No, he's not hiding, but he's keeping quiet. And indeed, in almost all scientific popular videos on this topic at this very moment of the story, an eye or something of the sort is being drawn on the screen, so that the viewer has no doubts and a stable association is formed. We are just watching, we are not doing anything else. A heartfelt thank you. By itself, so more interesting. After all, if you show that an electron beam is placed in a magnetic field for interference observation, all the mystique immediately flies away. And it becomes clear that this very magnetic field has some substantial effect on the passing wave flow and somehow structures it. It seems obvious, but from such an understanding of the experiment, it's not far to a full understanding of the ether, to a new understanding of electricity, and God knows what other discoveries science will make in this direction. By the way, have you noticed how smoothly and imperceptibly in the experiment, the light wave was replaced by an electron flow? It seems like a meaningless change, but still, an electron is a particle, and light is supposedly a wave. And the electron, as is known, is very susceptible to the influence of electromagnetic fields. So expecting changes in its behavior in an electromagnetic field would be more than natural. Why in the experiment did they stop using quanta, that is photons, and replace them with much more massive electrons? Maybe because it's easier to release electrons, or do they also behave like a wave? Well, decide for yourself, and we will continue with you. Quantum physics has given birth to many strange and seemingly inexplicable phenomena, such as paired particles, virtual particles, the concept of spin, quantum entanglement, and the like. Chimeras, for example, one of the seemingly difficult to explain chimeras is the pairing of particles. Moreover, their spin, that is, the direction of their spirality, rotation, will be precisely opposite to each other. Moreover, no matter where in the universe, no matter how far apart these particles are from each other. But in reality, this is just a consolation. In itself, no one has checked the state of different particles at different ends of the galaxy. All these are just results of mathematical equations and assumptions. In general, mathematics, as we have already convinced you in previous videos, is the most powerful tool for proving or justifying anything at all. And many formulas, if not all, on which modern quantum and even ordinary physics are based, are the result of correlations of different data which may not even be related to each other. And if something doesn't fit, you can always add some coefficient that seems to mean nothing, but makes the formula work, as it was in the case with the gravity formula. Now you can correlate and derive any formulas directly online based on this. The method has long been tested and worked out, inputting your values directly online on the site and getting the result. For example, you can compare your body temperature indicators throughout the day with the duration of commercial breaks on REN TV. And in a second, the computer will not only give you the dependency, but also provide a ready-made formula according to which you can further predict the state of your body temperature depending on the advertising on REN TV. If after a couple of weeks of observation the formula proves its validity, and most likely it will, then it is correct. That's how modern science works. But such a method of correlation does not give an understanding of the process. You have to invent new entities, come up with all new chimeras so that the formula works more accurately. For example, the same spin. The directions of rotation of two entangled quantum particles will always be opposite. Why? Even Einstein couldn't answer this question. Because it turns out that in such a case, information is transmitted through the universe instantaneously, which, as you understand, is much faster than the speed of light. Paradox. But no one has ever seen these particles. We've only seen some manifestations which were interpreted, and conclusions, assumptions were made based on these interpretations. And all new interpretations and new assumptions. And what if the very first key interpretation is wrong? Then all the others, which are based on it, will also be wrong. All understanding of quantum physics collapses, except for the formulas. Strangely enough, they will all remain fully functional, as they are created and honed based on the correlation of a huge amount of information and data. Correlations. Yes, what can I say? Mathematics is a powerful tool. But still, what if Max Planck accidentally or intentionally misinterpreted his very first experiment? So, let's go into more detail from this point. Max Planck is a German theoretical physicist, not a practitioner. And this means, first of all, that he did not conduct any experiments, only mathematical construction of formulas and dependencies based on existing data. In other words, he did exactly that, correlated and looked for interdependence. And in 1898, he tackled the problem of thermal radiation. And by 1900, he finally got the correct formula for the distribution of energy in the spectrum of an absolutely black body. That is, before this, there were a lot of incorrect formulas. And this was associated with a physical paradox, the so-called ultraviolet catastrophe. Various scientists grappling with this problem repeatedly mathematically proved in different ways that the total power of any heated body, according to Rayleigh-Jean's law, should be infinite. Moreover, the formula worked fine for long waves, but the shorter and denser they became, the more the result differed from reality, eventually going to infinity. And Max Planck solved this problem, finding not at the first attempt the kind of function that corresponded to the experimental data. For this, he assumed that the radiation, in our case light, goes not in waves but in portions, quanta, and there is nothing between them, and the quanta themselves turn out to be some kind of particles. Thus was born the concept of a quantum in all of quantum physics. At this point, let's take a small pause and clarify once again. Let's emphasize a couple of details. First, Max Planck was a theorist, and second, Max Planck, like many of his famous contemporaries, was engaged in the fact that he was selecting formulas that describe reality. That is, there was no understanding of reality, as probably there is not now. Therefore, they used the same data correlation and selection of correct options. In layman's terms, this method is called the scientific poke method. His guess was close to the truth, but that doesn't mean it didn't provoke contradictions. For example, Hendrik Lorentz practically immediately found a mass of glaring inconsistencies and absurdities in it. According to the calculations, some contradictory miracles were obtained. For example, a quantum should have interfered with itself because, according to the calculations, its length turned out to be several centimeters. Imagine centimeters. And if we look at the light of any star, then the photon, having flown to our eye, should have about 100 square centimeters in cross-section. Once again, 100 square centimeters. For comparison, the entire eye in cross-section has 4.5 centimeters, and one photon, 1/100th of a photon. That is, it occupies the area of 2 packs of cigarettes. But any device that absorbs energy, including light, for example, our eye, to see a star, must swallow a whole quantum, all the portion entirely, otherwise you won't see anything. The photon leaves no traces of its presence on the retina of the eye, and it cannot accumulate in pieces. By the definition of the same Max Planck, either all at once or nothing. Among other things, an entire section of applied physics, photometry, is based on this effect. The principle of spectral analysis is based on the fact that energy and light, including, are transmitted in portions and are also absorbed by these same portions. Either swallowed the whole portion at once or missed it. But how can an eye swallow a whole photon at once, which is over a centimeter long and can be as wide as 2 packs of cigarettes? But they simply won't fit into the eye's pupil. There were so many contradictions in Planck's theory that they were called quantum effects. That is, the assumption made to solve one single paradox solved it, but gave birth to an unimaginable number of new ones. Then you might ask, why all this? One could simply have named it the paradox of the ultraviolet catastrophe instead of spawning 1,000 new ones. It was worth it. Yes, if the real task was not to solve the paradox, but to remove the ether. Nevertheless, the assumption that energy is consumed in quanta did solve this paradox. So it has some relation to the true nature of things. Perhaps we need to try to explain this effect from a different perspective, in which the wave does spread within the ether medium. Is this possible? The sea is waving, right? Let's remember how we perceive the wave. Schematically, these are zones of compression and stretching of the medium. This is always drawn on simplified diagrams when something needs to be quickly explained. This is how both Huygens and Newton perceived the wave. Remember his phrase about ether as a liquid medium? But even then, it was clear that such a scheme is not entirely correct. Because in a liquid, only longitudinal waves are possible, and transverse ones are found only in solid bodies, for example, in metals and crystals. The electromagnetic wave has both longitudinal and transverse characteristics. And since the ether is clearly not metal, then the Huygens-Newton assumption about the simultaneous existence of two ethers arose. Some people, by the way, are now advancing the hypothesis on this basis that the ether is a crystal. Well, that's how it is. Let's leave this in memory for now and recall my old video, Sign of God, in which I explained what the cross means and how it is connected with the act of creation. Compressing the ether to a certain density gives birth to a particle, that is, it is born out of nothing. So, if the ether is so rarefied that we do not feel its materiality, then for us to observe it, it needs to be compressed. Light waves moving in the ether, as clearly defined, pass through areas of compression and expansion. And encountering any obstacle, for example, a sensor or a mesh of the eye, it begins to exert pressure on it, accumulating its energy. This very pressure accumulates until the density of compression reaches the point where the eye can already fix it. After the absorption of a portion of energy, it begins to accumulate from zero again until its quantity reaches the fixable level. This is how quanta of portions appear. Now about the wave itself, a two-dimensional drawing does not give us a full understanding of the structure of the wave. To understand what it looks like, a three-dimensional model is needed, and it shows that the wave is a coiled spiral. In the case of an electromagnetic wave, it is a coiled double wave, that is, a double spiral. One of them is electric, the other is magnetic. In case these waves are not only synchronous but also in phase, that is almost completely coinciding, then the wave looks something like this. Stop, I made a slight mistake. This is a DNA spiral, and this is what an electromagnetic in-phase wave looks like. It may not be a mistake, but it's complex to explain. Check my video series for detailed explanations. What does DNA say? So, a wave is a spiraling stalking, another wave or an obstacle. It can compress and at some point give birth to particles. First, just pieces of fixed energy, quanta. They don't live long. Microseconds then again dissolve in the ether. And this does not contradict the postulates of quantum physics. But if a wave gives birth to such particles, meeting, for example, an obstacle, then it will give birth to them in pairs, and these particles will be synchronized. And since the spiral is double, then the spin, that is, the direction of one particle, will always be opposite to the direction of rotation, the second pair. And again, no matter where in the universe the paired particles are, no matter how unimaginable the distances, if this particle is part of one wave, then their spins will always be opposite. And for this, you don't need to invent an instantaneous data transmission at speeds higher than the speed of light, invent chronologic quantum paradoxes. No, everything is explained simply and banally. Both particles are part of one wave. In other words, the presence of ether can explain many paradoxes of quantum physics. But it would be quite healthy if the presence of ether somehow explained it. And that very first mathematical paradox, called the ultraviolet catastrophe, with which it all began. Let's try it this way. According to the definition, long electromagnetic waves fully complied with the action of the Earle-Jones law. But as the frequency increased, the power of the wave went to infinity. But perhaps not to infinity, because what is such an increase in frequency, if not the densification of the wave, but accordingly the densification of the medium in which this wave goes, the ether. And in the end, the wave could, according to this formula, condense so much that it transformed into a particle, into real matter, with which slightly different laws already operate. In essence, the power of any atom is immeasurably, infinitely above the power of any wave. And from this, by the way, another interesting point follows, that the reverse effect is possible. Matter atoms can disintegrate into waves, but since the atom itself is an electromagnetic wave of infinite power, the decay will be accompanied by the release of ultra-high frequency waves first. That is gamma radiation, which will then slightly stretch and turn into X-rays, then visible light, then into heat radiation, and then into a radio wave. But this understanding is too close to understanding how to create anything out of nothing to free unlimited energy. No capitalist, no ruler will allow further steps of science in this direction. Apparently, that's why all forces were unleashed. All the scientists of that time were focused on resolving the ultraviolet paradox in another way. Hence, they reconciled with the birth of a good 100 new, even more impossible paradoxes. Instead of one, it was impossible to allow another step. The continuation follows.